Okay, guys, here's your warm-up. We spent 2 days talking about parallelograms. We spent 1 day talking about its properties. There's 5 of them. Then we spent the second day proving parallelograms, like, hey, what does it take to be a parallelogram? Which of these are and which are just pretenders? So this warm-up is just a basic, hey, can you apply one of the properties and solve for missing angles? So go ahead and try this warm-up. So we have angle BAD, which is kind of a fancy way for just saying in this shape, just angle A, 3x minus 12 degrees. ADC, x plus 40 degrees. And honestly, guys, you could have solved this problem before I taught you a single thing about parallelograms, because you could have said parallel lines cut by a transversal, same side interior angles, same side supplementary, same side supplementary. So the biggest mistake students make is they see 2 expressions and they just set them equal because they think that's what you do every time. So as long as you were using a little bit of thought in this problem, you would have added them to equal 180. Consecutive angles are supplementary. Add them to equal 180. You get that x equals what? Very good. X equals 38. You plug it back in. Now we're trying to find angle BCD. That's a fancy way of saying angle C. Which angle would be congruent to angle C of the angles that we know? Angle A, because opposite angles are congruent. So you plug it into angle A, you know that it's congruent to angle C. Final answer, 102 degrees. Awesome. Oops, sorry. Today's lesson is rectangle, rhombus, square. Sorry, I hadn't pressed record. Otherwise known as special parallelograms. So these shapes right here are sometimes called special parallelograms. That's kind of to remind you that these shapes are a parallelogram. They are a quadrilateral. But they're kind of a parallelogram who's been promoted. A parallelogram who's done something extra, so therefore they get a whole new name. They're special parallelograms. So we're going to fill out the rest of our family tree on the right side today. Let's start with rectangles. A rectangle is a parallelogram, but it's a special parallelogram, and we're going to find out why. So because a rectangle is a parallelogram, it inherits all of the properties of a parallelogram. For example, do you have the same eye color as one of your parents? Probably. Do you have the same hair color as one of your parents? Possibly. You inherit traits from your parents. Well, the parallelogram inherits traits from the parallelogram. So all 5 of them is true in a rectangle. All 5 of them. No and no. Great. Here's the definition of a rectangle. It's also property number 1. Don't write it down yet. By definition, a rectangle is a parallelogram, first and foremost, but it's a parallelogram with 4 right angles. So the rectangle did something good. He had 4 right angles. He received a promotion. Here are the 2 what I call bonus properties of a rectangle. It's on top of the properties that he already had. Property number 1, take a look at the picture. 4 right angles. You already know this. I know you learned this forever ago, so let's write it down. 4 right angles. The second property, what do you think this picture is trying to convey? What do you think the second bonus property is of a rectangle? Good. Those diagonals, they are the same exact length. The same length. The reason for this is that rectangles have good posture. They're standing up straight. So a parallelogram is kind of lazy. His diagonals are not congruent, but as soon as he stands up straight and he becomes a rectangle, his diagonals became congruent. 2 bonus properties. Know them, memorize them. All right. Moving on to a rhombus. We've got a tail light on this car. That's a rhombus. We've got some turquoise jewelry. We've got a rhombus. Get it? School bus. Okay. So anyways, what is the definition of a rhombus? So a rhombus is a parallelogram with 4 congruent sides. Very good. A parallelogram with 4 congruent sides. You don't need to write that down because that is also property number 1. You can write 4 congruent sides or you can write all sides congruent. So a rhombus has more than just opposite sides congruent. It has all sides congruent. Ooh, what is this next picture trying to convey? What is rhombus bonus property number 2? Very good. The diagonals are dun, 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 perpendicular. So every time you're given a rhombus, I want you to go to the picture and add 4 right angles where the diagonals intersect. 90, 90, 90, 90. The diagonals of a rhombus are perpendicular. There's going to be one other shape in your family tree that this happens to. We'll learn about it next week. All right, last bonus property. He's a little bit more special. He gets one extra bonus property. What is this trying to convey? The diagonals, good, bisect the angles. The diagonals cut the angles in half. You don't necessarily need to write the word opposite if you don't want to. Diagonals bisect angles. So we had 5 properties of a parallelogram, and we just added on 5 more between rectangle and rhombus. So it's now 10 properties that you are getting to know really well. Hopefully. All right, guys, we made it to square, the king of the land. The square is extra super special because the square is everything. A square is a parallelogram with 4 right angles. Oh, that makes him a rectangle. And 4 congruent sides. That makes him a rhombus. So a square is a parallelogram that is both a rectangle and a rhombus. He is so special. Yep, the king of quadrilateral land. Quadrilateral landia? That's funny. King or queen, doesn't have to be male. Queen of quadrilateral landia. You don't need to write this down. A square just simply has all, how many properties? All 10 properties. All 10. Yep, that's what a square has. Cool. What is there to do now other than try to solve some problems with our new information? So draw this figure in your notes and see if you can find all 8 missing labeled angles. The way that these shapes work is when in doubt, you read a property from your list. When in doubt, you read a property. Now, rhombus has 4 congruent sides. That might not really help us with the angles today, okay? Let's read the next property. In a rhombus, the diagonals are perpendicular. Well, look at that. I just solved for angle 3. 90, 90, 90, 90. All right, let's read another property. In a rhombus, the diagonals cut the angles in half. They bisect the angles. Look at that. Arc, 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 arc. So let's just start finding all the missing angles. 22, 22. Oh, in a parallelogram, opposite angles are congruent. A rhombus is a parallelogram, so 22, 22. All right, one way to find angle 8 would be to look at this right triangle right here. When you have a right triangle and you know one of the acute angles, you can just subtract that angle from 90, actually. 90 minus 22 will get us 68. The diagonals bisect the angles, so 68, 68, 68, 68. How many different angles are in this picture? I mean, if you don't count 90, there's only 2 different angles, right, at the exterior. So in a rhombus, I mean, that'll happen every time. There will only be 2 different angles. There'll just be 4 of each of them. Yep. All right. Let's try a rectangle problem. We have rectangle rock. Try to find the perimeter of that rectangle. All righty. Did you get, let's see if I can remember, 6 plus 12 root 2? So what did we know about our picture to begin with? We knew RK was 3 and we knew RC was 9. Now, when in doubt, look at your properties. The first property in the definition of a rectangle is that it has 4 right angles. So we have ourselves a right triangle. We have a right triangle that has a hypotenuse of 9 and a leg of 3. So to find this side, we need to do Pythagorean theorem. 9 squared minus 3 squared is 72. the square root of 72, 6 root 2. So this is 6 root 2. So if I find the perimeter, I add up all the integers first. So we add all the integers, 3 plus 3, opposite sides are congruent, and we get 6. We add all of the radicals, 6 root 2 plus 6 root 2, and we get 12 root 2. No, we cannot combine it. Yes, this is our final answer. The perimeter is 6 plus 12 root 2. Here's another rectangle rock, same rectangle. Now we're going to find some missing angles. See if you can solve for the missing angles in a rectangle. All right, we know the angle ROK is 49, and that's all we know. And we're supposed to find all of those missing angles. Now, this rectangle problem is a little bit different. I would start by just assuming it's a parallelogram, and I would go as far as the parallelogram would take me. For example, in a parallelogram, we have parallel opposite sides, so we can do alternate interior angles. And actually, now I'm stuck. That's all I can do parallelogram-wise, right? So now we can use a rectangle property, and we can say, hey, I know that a rectangle has 4 right angles. I know by angle addition that angle 3 plus 49 will equal 90. So I now know angle 3, 41. I could even go over here and do 41 alternate interior angles. Now I'm stuck because I can't find any other angles using the properties that we've had in the past. So now we need to get a little bit creative. But this is a cool thing about rectangles, and it happens in every rectangle. Not only do the diagonals bisect each other, but what else did we add to our chart? Diagonals are congruent. So if this diagonal is 8 and this diagonal is 8, and they both bisect each other, what kind of segments do you get? 4, 4, 4, 4. Wait a minute, they would all be 4, right? So what that means is that the diagonals bisect each other, and all 4 of those segments are congruent. Now, that's all well and good, but we're not looking for segments, Miss Stanton. We're looking for angles. Well, we can use the fact that it creates a certain kind of triangle. What kind of triangle is created? Only in a rectangle. Isosceles triangles are created. 4 isosceles triangles are created. And we know by the isosceles triangle theorem that base angles are congruent. So if 2 sides are congruent, then the opposite angles are congruent. Arc, kind of like that. 49, 49, kind of like that. And then we look at angle 1 here. We've got isosceles triangle. And then we can simply do triangle sum theorem with 49 and the 49 and angle 1 right there. 82 degrees. It's getting a little messy, but you know what I mean. Okay? Last problem that we're going to solve. We'll do a few true falses after this, but last solving problem. Perimeter of triangle LNO. Whoa, those answers were really quick. Okay, we know in a square that a square is the cream of the crop. He's everything, she's everything. So if you wonder to yourself, do the diagonals bisect the angles? Sure they do. Are the diagonals congruent? Sure they are. It's all true in a square. So if that angle is 90 and 90 was bisected, then those angles are 45 and 45. So when you draw a diagonal of a square, you create 2 isosceles triangles. Good. So we can use our shortcut, 12, 12, 12 root 2, 12, 12, 12 root 2. So if I wanted to find the perimeter of LNO, it would be 24 plus 12 root 2. No, we do not combine an integer with a radical. Good. True or false? Sorry. All squares are rectangles. All squares are rectangles. True? Did you hear it ding? Good. We're going to come back to this one because this is the hardest one. I don't like how it's listed second. All parallelograms are rhombi. All parallelograms are rhombi. Good. False. Some rectangles are squares. Some rectangles are squares. True. Okay, what about this one? Some rhombi are rectangles. I taught you how to go up the family tree and how to go down the family tree, but I never told you what happens when you try to go sideways. True or false? The answer is, it's not false. It is true. Let's talk about it. Some rhombi are rectangles. So, do you agree that a rhombus could be a square sometimes? Do you agree? A rhombus is sometimes a square. Yes. Now, if a rhombus is a square, is it also a rectangle? Oh, yes. So it's really weird logic. It's weird reasoning. But if a rhombus gets promoted to a square, then it is also a rectangle. If a rhombus is a square, then it is a rectangle.